That's some clean water. And I know that because it's in a bottle by a company who cleans their water. That being said, you don't always know how clean the water you are using is. Take for example, what if I needed to get my water from this faucet? How clean would that be? Well, now we have a way to test it using the HITA water filter. Yuck! This is the HITA Water Tester. It involves very many disciplines, including ones with electronics and coding via cyber engineering. We have managing water pressure and the mechanics of water, that is mechanical engineering. We have building and creating structures that could be considered as mechanical, civil, whatever you want to call it. And we have managing the electrical circuits and components of the electronics, which is electrical engineering. That is our disciplines that we used. How clean is this water? Let's see.
So you can see it's out of water. My friend here, my partner Hunter, is going to turn on the faucet and we're going to demonstrate how this works. So you can see water is currently going into the system, and our HITA Water Tester is currently assessing the water that is in the water composite that you can see here in the bottom. Right now it's drinkable, 96 ppm. It's kind of rising. Our sensor is picking up the drinkability of the water. It's highlighting certain things that are in the water, and as you can see, the water fills up to a certain level, and then it exits the HITA Water Tester. So in real time, test your water. Yeah, guys. Please like and subscribe. It's reading good values now, but for whenever there is a boil ban or boil advisory, of course the ppm values would surely rise in this situation. But as of now, there's no boil ban and water's safe to drink. So if you're really thirsty, dying of thirst, you could drink this water.
We have a structure built by Alex that contains a compartment for electrical that we keep waterproofed and sealed off from the rest. We have our water composite that will build up water all the way to the top. And as it builds up water, it is coming from this hose who goes all the way down to the bottom. And as the water builds up, it comes through the top hose and comes out with similar pressure to where it began. So everything is sealed off from each other. This is an attachable and detachable threading for default sizes of faucets. Unfortunately, this one is not a default size faucet. The electrical components is the TDS sensor, the LCD screen, and the battery pack, so it is portable, as well as an Arduino Uno and a breadboard. The way this works is it will continuously loop and scan the TDS values, and as long as those values are consistent and not jumping very quickly, it will continue to give you those values. But if it starts to jump very quickly, it will then say assessing. That way you don't get a bunch of random values, and then you'll get your average whenever it levels out.